Previously, we looked at some permutation or combination situations where there are extra requirements. Now, in this video, we want to look at one special requirement that the permutation must be grouped together. That means if you want to line up the things, some of the items, they must be grouped together. They cannot be separated, all right? So it is only for lineup, obviously. It is only for permutation. It does not apply to combination. For combination, we do not have the idea of togetherness, all right? Because you just put the selected objects into a bag, right? So there's no together or separate. But in permutation, you have things that are put together, you have things that are separated. So we have to consider this. So let's take a look at this example, right? So you have, in this example, you have 5 boys and 3 girls standing in a row, all right, from the first one to the last one, 8 persons all together. So what is the total permutations? Total permutations, well, no requirement. It doesn't matter whether each one is a boy or a girl, right? So just look at the total permutation. There would be 8 persons, all right? You line them up together. So the answer is 8p8. You line up 8 persons. So the answer goes to 40,320, right? This is the standard one. AP8 for line up 8 persons, or in other words, it is a factorial, all right? It is just a factorial. Now, however, here comes the important part in this video. What if the boys in part B, what if the boys must be together? All right. Among all these different lineups, how many of them will have all the boys stand up together? Which means that you can have the 3 girls, like girl 1, girl 2, all right? And then the 5 boys, B1, B3, B4, B5, B2, all right, like that. And then the last girl, right? This is okay, right? You have the boys together. This is okay, all right? But now permutations like that will not be okay. You have B1, B4, and then you have a G1 here, and then you have the B5, B2, B3. Then the boys will be separated into 2 groups, right? One of them will be B1 and B4. The other will be B5, B2, and B3. So this is not okay, all right? Because in this case, the boys, they are no longer together, all right? We want all the boys together as a group, all right? So this is the meaning of the boys must be together. All right. So the question now is, how do we calculate this? How do we calculate the number of permutation when some group must be together? All right. So to do this, you can imagine this method. You take a box. All right. You take 4 boxes. All right. There are 4 boxes. In the first box, you put G1 into the first box, the first girl. The second girl you put in the second box, and the third girl you put in the third box. Now for the 5 boys, you put all the 5 boys into the same box. Alright, so this is one box with all the 5 boys. So it becomes a 2-stage permutation. 2-stage permutation. In the first stage, you permutate these boxes. Alright, now because I put all the boys into one box, so no matter how you do this permutation, the boys will always be in the same box. Alright, so you can rearrange the order. You can put G3 behind it, you can put the boys in front, whatever, right? No matter how you shuffle the boxes, the 5 boys will always be together. Alright, the 5 boys will be always in the same box. Alright, so no matter how you shuffle the boxes, alright, no matter how you shuffle the boxes, the boys will always be together. Now, we are making use of this method to calculate that things must be together. Alright, we design a box and put all the boys into that box. And then each girl, they have no limitation. So each girl will have her own box. Alright, so altogether, there are 4 boxes. To line up these boxes, you have 4p4. Alright, 4p4. But don't forget, for each of these lineup, if you open up the box with the boys, you can also line up within the box. Alright, within this B1 to B5 box, you can line them up in B1, B2, B3, B4, and B5. Or you can line them up in any way, B5, B4, B1, B2, B3, whatever. Alright, because this box, there are a number of varieties. There are many varieties for the internal permutation of this box. So how many internal varieties are there in this box? Right? If you open up the box with the boys, then you can line them up in 5p5 ways. All right, that is the internal arrangement, the internal arrangement of the group of boys, right? So at the end, because it is n, all right, for each of these girl combination, you can match up with one of these boy combination. So it is a multiplication between the two. The answer will be 4p4. That is the permutation of the boxes. All right, multiply to 5p5. 5p5 will be the internal permutation of the boys. So the answer goes to 2,880. Alright, so by similar token, can you figure out how many total permutations are there if the girls must be together? Alright, if you understand how do we calculate the number of permutation if the boys must be together, right? We make a box to put all the boys together, and each individual girl, they got their own boxes. So it becomes a two-stage permutation. You line up the boxes, and then you open each box and line up what is inside. Alright, that is how we did it. So how about the girls? You may want to pause the video and think about it. Alright, you may want to pause it now. Alright, I believe you have the answer now, alright, or at least you tried, alright. So well, once again, we get a box, alright, and then in this box we get all the girls inside the box. Alright, we have G1 to G3 in this box, alright, and then we have one box for each boy. Alright, there are 5 boys, so we have 5 boxes, one box for each boy. Right, so we have B1 all the way to B5, okay. So now there are altogether 6 boxes to line up. Alright, there are altogether 6 boxes to line up. So the way to line up the boxes will be 6p6. Alright, there are so many ways to line up these boxes. For each of these permutation, you can open up the green box and line up the 3 girls. So how many ways are there to line up the 3 girls? 3 girls, we line up 3 of them, so the number of ways to line up the box is 3p3. Alright, for each of these orange permutation, you can open the green box and line up the 3 girls in the green box. So once again, you multiply these two numbers together, the answer goes to 4,320. Alright, the girls must be together will be 4,320. Alright, so this is how we calculate the permutation if things must be together. Let's take a look at one more example. Alright, instead of 2, now we have 3 different items. We have 2 different Chinese books, 3 different English books, and 4 different mathematics books. Alright, we have red, green, and blue. In red, in green, in blue. Alright, we have this. Now, so first of all, in part A, how many ways are there to line them up on the shelf? Right? Regardless of language, regardless of subject, it can be Chinese, English, or maths, it doesn't matter. If that is the case, how many ways you can do that? Alright, so that means you have 9 books altogether. 2 and 3 and 4 is 9. So if there's no limitation, the number of ways to line them up is just 9p9. Alright, and that goes 362. 880. Never mind the numbers, right? What is important is it is 9p9 or it is just 9 factorial. Alright? No restrictions. Now what if the math book, they must be together? The math books, they must be together. So we take a blue box and put all the math book inside. Alright, so we have M1 all the way to M4. And then each of the other books, we have one box for it, right? Because the Chinese book, they do not have to be together. So it can be C1 and C2. They can be together, they can be separate. So each has its own box. Alright. So English, once again, 3 boxes for the English books. Alright. Because there's no limitation, there's no restriction on the English books. So they can be together, they can be separate. I don't care. Alright. What I concern is the maths book must be together. So I put them in a box. So there are altogether 1, 2, 3, 4, 5, 6 boxes. So to line up these 6 boxes, we have 6p6. Alright, 6p6 ways to line up these boxes. And then if for each of these permutation, for each of these 6p6 permutation, you can open up the blue box and line up the 4 maths book inside. So how many ways are there? How many ways are there to line up the maths book? The blue box, there are 4p4 ways to do that. So the final answer is the multiplication between the two, and the answer goes to is 17,280. All right, this is the answer to part B, if the maths books must be together. All right, so similarly, you can calculate the number of ways if the Chinese books must be together, if the English books must be together. All right. Now let's take it to another level. Now look at part C. All right. What if books of the same subject must be together? That means the Chinese must be together, the English must be together, and the mathematics must be together. All right, books of the same subject must be together. So how many boxes you should prepare? How many boxes you should prepare? You should prepare 3 boxes. All right, 1 box for the math book, M1 to M4. 1 box for the Chinese books, because the Chinese books cannot be separated, so you have to put them in a box. All right, and then a final box for the English books. All right, that would be E1, E2, and E3. All right, so there are 3 boxes, and then you can line up the 3 boxes. The ways to line up the 3 boxes will be 3p3. All right, we have so many ways to line up the 3 boxes: Chinese, English, and maths. All right. Now for each of these permutation, you can open up the blue box and line up books in the blue box. To do that, we have 4p4 ways to line up the maths books. And similarly, for each of these blue permutation, you can open the red box and line up the 2 books there. Right? You can do it in 2p2 ways to line up the Chinese books, and similarly for the English books. All right. So the answer goes to something like this. Now look at these 3p3. They do not come from the same origin. All right. The first one, they are the boxes. The black one, right? We have the maths, Chinese, and English, 3 boxes. We permutate the boxes, so we have 3p3. All right. But the last 3p3 in green will be the internal permutation. The internal permutation of the English books. All right. So this answer goes to 1728. All right. If books of the same subjects must be together. All right. And finally, now we have even more restriction, right? What if the English books must be together and put on the left? In other words, you can have the English books together, right? E1, E3, E2, but they must be on the left. And then the Chinese book, the maths book, you can put it in random order. It doesn't matter. All right. And then you can have M4, M3, M2, and then C2. This is fine. All right. You must have all the English book on the left hand side, but the Chinese book and the math book, they can be put in random. But you cannot put a math book on the left hand side, right? Like this, cannot. All right. If you do this, then it is not okay, because you have the math book on the left hand side is not okay. All right. So that is the meaning of the English books must be together and on the left. All right. There cannot be any book in front of it. Okay. So how do we do that? Think about it. So once again, we prepare a green box. All right. The green box, we put the 3 English books inside. And then you have 1 book for each. You have 1 box for each book. How many books are there after you take out the 3 English? There are 2 Chinese and 4 maths, right? So never mind what they are. So there are 6 other books. All right, Chinese or maths, doesn't matter. All right, so now because the English book cannot move, right? They must be there. The green box must be on the left-hand side. So the only way you can permutate is to permutate the orange boxes there, be them Chinese or maths books. All right. To do that, you have 6p6 way to line up the orange boxes. Do you agree? For each of these orange lineup, you open up the green box, all right, and line up the 3 English books. To do that, you have 3p3 ways. So the answer is the product of these 2 numbers, 3p3 times 6p6, and the answer goes to 4,320, all right. So you see, in these two examples, we employ a variety of strategies to how to turn the situation into something we can calculate, all right? And particularly, we learned how to do the situation when the items must be together, all right? So this is it for this video.